Hi everyone, and welcome to the section 3.2 video. In this video we're going to be talking about the product rule and the quotient rule. And so this is just going to add to our list of different methods we have for taking derivatives. And what you'll see here is this is going to kind of follow through a lot of things we've seen before, where these rules are just how do I take easier functions, combine them into a more complicated one, and then find a rule that kind of helps me break up this more complicated function into simpler ones. So the product rule is given here. If f and g are both differentiable, then if I take the product, the derivative is this mix of both f, g, and their derivatives. So this is a lot to look at. The easier way to try to remember this is using prime notation and getting rid of these x's. And that's this way. So you see here we have the product fg. The derivative of the product is fg prime plus gf prime. So this is just you mix f and g, priming each of them once, right? So basically f, g, f prime, and g prime all get to show up once, and they're mixed with the other function and always one derivative, one not derivative. Now, for us, it actually doesn't matter with this if you mess up remembering this in a few ways. So if you accidentally remembered this plus fg prime, fine. If you ended up remembering f prime g plus g prime f, that's also fine. This is addition and multiplication of functions. We can do that in any order. So all you need to make sure is that these each show up once and that they're mixed. So f never goes with another f, okay? G never goes with another g. F and g always have to go together, and it's one prime, one not prime, okay? So fg prime plus gf prime. But again, you accidentally mess up the addition order, or you flip g prime f instead of fg prime, that doesn't matter. So you can go into the book, and I'm sure there's a bunch of YouTube videos too that kind of talk through, what's going on with this rule, the why a little bit more, and we're not really going to focus on that. What I want you to do is just practice using the rule as much as you can, okay? So that's what we're going to do for the rest of this video for the product rule, is just really practice as many of these as we possibly can. So let's think of a couple different examples to do. Okay, so for the first example, so let's write examples here. We want to take the derivative of x cubed plus 2x e to the x. So first thing you have to do is notice I'm multiplying two functions. That's always step one. What am I doing? I'm multiplying. Okay, got it. So that means product rule. Then what you can do is you can identify. This is f, and this is g. Okay, now get everything together. F is x cubed plus 2x. G is e to the x. F prime is 3x squared plus 2. G prime is e to the x. Now plug into the formula. The derivative of this is going to equal, so d dx of that is going to equal what? Go back to the formula. It's right up here, right? So x cubed plus 2x e to the x, that's that g prime, plus take g e to the x, and then your f prime, 3x squared plus 2. It is easier when you're starting off to separately do these out, right? The f's, the f prime, the g primes, then plug into the formula. When you get quicker at this, you can kind of do some of this f prime, g prime in your head and just go straight to the formula. But for now, I would say stick with writing the functions and the derivatives out, then going into the formula. Okay, let's try another one. So we're going to do the derivative of, and let's find a good one here. We can do one that's a little trickier looking maybe, of 1 over y squared minus 3 over y to the fourth. and then we've got y plus 5y cubed. Okay, again, first step is I have to recognize this as multiplication. This is f, this is g. So then f, just to rewrite it, and actually what we could do here instead of rewriting it in its current form is rewrite it in a way that's going to be more helpful for doing the derivative. This is actually y to the negative 2 minus 3y to the negative 4. So that derivative would be drop it down, subtract, right? Drop it down, subtract. Okay, so hopefully that's not too terrible to rewrite it and do the derivative. And then here g is y plus 5y cubed. G prime is 1 plus 15y squared. So then the derivative will equal, and then just have the formula with you when you're starting. It's okay. fg prime plus gf prime. F, and you can rewrite it in whatever form you want. G prime. I'm just looking right at my little work here to grab that. Plus gf prime. And then f prime. And again, you can put this in any form. You can put things back on the bottom if you don't want the negative exponents. That's fine too. Plus 12 over y to the 5th. I mean, it's messy. It's not the nicest thing in the world, but it's the derivative. So find your f, find your g, take the derivatives, plug into the formula. Done. Just go practice as many of these as you can find. And of course, in the additional resources, I'll put some more examples, videos that you can go watch people do more of these. But that's it. You just got to go, 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 go. Okay, so there is another rule called the quotient rule. Again, it's got this much worse looking formula, depending on the notation you use. But if you use this prime notation, it's not too bad. And there's a mnemonic device that can help you as well. So if I have f over g and I do the derivative, it's gf prime minus fg prime. Notice here, subtraction means order matters. You can't flip these two. It's not going to work because you're subtracting. So we have to remember this one exactly as it is, over g squared. Okay, so what's the kind of thing? You might find other things online, but the one that I had learned was low d high minus high d low over low squared. And that might kind of be like, what? But then say it fast. Low d high minus high d low over low squared. Low d high minus high d low. It kind of has a little ring to it. So if you do it that way and you kind of give it a little get a little music behind it, it's not too bad to kind of get that in your head. Low d high, low being what's on the bottom, the lower function, g. D for derivative high, f is on top, minus high, f, d low, derivative of the lower function, over low squared. So low d high minus high d low. Low d high minus high d low. That's how we remember the top. Okay, so let's try an example. A couple examples in here. So let's do the derivative of e to the x over 1 plus x, e to the x. So again, I'm looking at this and I'm like, okay, yep, I see a division sign, so I'm thinking probably quotient rule. Doesn't necessarily have to be, but in this case it is. So f is this, g is this. So then let me write this here, e to the x, f prime is e to the x, g is 1 plus e to the x, g prime is e to the x. Okay, so then plug into the formula. Low, that's g, equal sign here. D high, derivative of the top, is e to the x, minus high, e to the x, d low, e to the x, over low squared. There you go. Now you can do some simplification here, right? This is 1 plus e to the x minus e, and then add in the exponents 2x over this. And I mean, you could do some factoring on the top too, but this is a fine answer. Boom. What's f? What's g? Do their derivatives, plug in the formula. Done. All right, let's try another one. How about, let's see, let's find a good one here. How about we can do another e. Let's do the derivative of e to the x over x squared. Okay, so again, I see a division sign. Quotient rule seems like it could be good. Here's f, here's g. So f is e to the x, f prime is e to the x, g is x squared, g prime is 2x. Low, x squared, d high, e to the x, minus high, e to the x, d low, 2x, over low squared. And again, you could factor an e to the x out. You can actually factor out an x. You could leave it like this too. That's fine. You can do some algebraic simplification if you want. I do want to make one note here that sometimes the quotient rule can be turned into the product rule. So watch this. This is actually e to the x, x to the negative 2, right? This is just the product rule. This is your f, this is your g. You can do the product rule here. You're going to end up with the same answer as over here. It might look different algebraically. You got to play around a little bit with that to simplify them into each other. But sometimes the quotient or product rule is doable. So just something to kind of keep in mind, back of your pocket. I guess the product rules may be a little easier here. Not really. They're pretty similar. So I wouldn't rely on this just always trying to do one or the other and switching going forward. You also need an additional rule we'll get to called the chain rule to turn into the product rule and be able to do it. This one just worked out, but just learn both rules, although you should just know that they are in some senses interchangeable. You can kind of go one or the other sometimes. So you just got to do a bunch of practice. There's really nothing else for me to say here other than practice, practice, practice. Okay? If you have any questions, of course, let me know. We can practice them together, and I'll see you in the next video.